Okay, in this I do problem, we are going to figure out what the empirical formula is. And then once we have the empirical formula, we will take a look and try to calculate what the molecular formula is. So the notes for this section describe the empirical formula as being the simplest whole number ratio of one element to another in a compound. And then the molecular formula is basically what is the real formula. So, in other words, like the formula for hydrogen peroxide is H2O2, but the empirical formula would be HO because it would be a 1-to-1 ratio. Um, so, to calculate the empirical formula, I think that the one thing I want you to focus in on is if you don't know what else to do, change everything to moles. Now, in your notes, they give you some information on how to determine the empirical and molecular formula. Make sure you read through this, make sure you take notes, make sure you highlight whatever you need to do. But there's some really good, solid tools to follow in order to help you do or to calculate empirical and molecular formulas. We're just going to work through this one right here. So let me bring up my pen and yep, that looks good. Okay, so it says a certain sugar used in treating patients with low blood sugar has the following chemical composition: 40% carbon, 6.7% hydrogen, and 53.3% oxygen. And we're going to calculate the empirical formula. When in doubt, convert to moles. And the key to doing this type of problem is we're going to assume we have 100 grams. Because if we assume we have 100 grams, then all of these percents can become masses, and then we can use molar mass to convert to moles. We're going to do this in order of carbon, hydrogen, and oxygen. So assuming we have 40 grams, 40% of carbon would translate into 40 grams of carbon. So we're going to say 40 grams of carbon. And the molar mass of carbon, so 1 mole of carbon has a mass of about 12.01 grams. And so that gives me approximately 3.33 moles of carbon. For hydrogen, we have 6.7%, so that's going to be 6.7 grams of hydrogen. And the molar mass of hydrogen is pretty much 1. I'm going to use 1.01. I'll just go to the 100th for all of these. And that gives me 6.63 moles of hydrogen. So we can see that the moles of hydrogen is about twice that of carbon. And then the last element we have here is oxygen. And 53.3% is going to translate into 53.3 grams of oxygen. And the molar mass of oxygen is pretty much 16. So I'm going to go 16.00 grams of oxygen. And that gives me 3.33 moles of oxygen. Now, it looks like we have a 3.33 to 6.63 to 3.33 mole ratio here. That's pretty much 1 to 2 to 1. Now, the easiest thing to do when you get to this point is just to divide everything by the smallest number of moles. Now, I'm going to write this out because here's what we have right now. We have C 3.33, H 6.63, and O 3.33, because those subscripts are really just mole ratios. So if we divide everything by the smallest number of moles, what we're essentially doing is at least making one of these so that we have 1. So I'm going to write this over here, 3.33, divide by 3.33, divide by 3.33. And so that gives us C1 H2O1. Or in other words, it gives us an empirical formula of CH2O. Now, this is our empirical formula. I'm going to put that right here. Empirical formula, empirical formula. That's our lowest whole number ratio. Now, it tells us that the molar mass is 180 grams per mole. So how do we know that we don't already have the molecular formula? Well, if I find the molar mass of this particular substance here, the molar mass of CH2O is pretty much 12 plus 2 plus 16. So the molar mass here is about 180 um, grams per mole over 30. So the molar mass of the CH2O is only about 30 grams per mole, which means whatever our compound is really 6 times the empirical formula. So if I take the molar mass, 180 grams per mole, and I divide it by the empirical formula mass, which is 30 grams per mole, I get about 6 times greater, which means I'm going to take this whole thing and I'm going to multiply by 6. So in other words, we're going to take CH2O and we're going to multiply that by 6. So our molecular formula ends up being C6H12O6. And this is our molecular formula. Talk about using the whole page. There we go. And that's it.